Okay, so our next part. So 2 today is page number 32. Right. So in previous lecture we studied okay, iterative methods. I'll revise that. Okay, what is aim? To solve system of linear equations. This is aim. Okay, two methods. One is yes, anyone? One is direct method. Direct method. Okay, what are the direct methods that we studied? Gauss elimination. Okay, second we studied LU decomposition. Okay, third we studied Cholesky. Okay, now today we want to study indirect methods. Instead of saying indirect methods, it is better to say iterative methods. That is, will obtain answer of unknowns x1, x2, x3 in each step. Understand what I am saying? In direct methods, we got the value of x1, x2, x3 at the end, right? Whereas in iterative methods, we are going to get answer at every step. Then now question will be, then why, if we are getting answer at first step only, why second step is required, why third step is required? To improve the answer. So whatever answer obtained at first step, that is not exact answer. I'll not say correct. It is not exact answer. So we have to improve it, and that will be improved in next few steps. Third step, fourth step, fifth step will going to improve the answer. Okay, iterative methods. So iterative methods, two methods are there: Jacobi iterative method and the second Gauss-Seidel. Okay, let me start. Jacobi iteration or iterative, one and same only. Jacobi iteration. Okay, so consider, write with me. System of linear equations as suppose the system is diagonally dominant. You understand diagonally dominant, na? Yesterday we studied it. Suppose system is diagonally dominant. Okay. Now write down. So from the first equation, write x1. Yes, what will be x1? B1 minus A12 X2 minus A13 X3, isn't it? And then this coefficient of X1 is A11. That will become like this. Okay. Find X2 from the second equation. So it is B2 minus A21 X1 minus A23 X3. A2 and X3 equal to 1 upon A33 Okay, understood how these three equations are written? Hope everyone is getting this. Suppose I start with, so say the first value of x1, x2, x3 is, let me start it with the 0. Right, x1 equal to 0, x2 equal to 0, x3 equal to 0. That is known as 0th iteration. Right? If it is given in example where we have to start, whether we have to start with x1, x2, x3 equal to 0 or specific value, say x1 equal to 1, x2 equal to minus 1, x3 equal to 1. That might be given in example. Usually it is not given. So we have to start with all the unknowns equal to 0. That is known as 0th iteration. Okay. From the 0th iteration, we'll find first iteration, second iteration, third iteration. Okay. So in the same way, the n plus 1th iteration is given by. So I'm writing formulas on the next page. Hope you might have understood this. So let me go through the next page. Right. N plus 1th iteration is, so x1, okay, I am writing it from the previous equations, x1 raised to n plus 1. This is not power, it means that it is n plus 1th iteration. That is equal to 1 upon a11. B1, this is constant. So for the whole example, it will remain constant only, minus a, what the equation was, a12. A12 x2, x2 will change, so nth iteration, previous iteration, minus a13 x3, nth iteration, right? Then x2 from the next equation, nth iteration, that is equal to 1 upon a22, right? B2 minus a21 x1 nth iteration minus a23 x3 nth iteration. Hope everyone is getting this. Okay. Then x3 n plus 1th iteration, that is equal to 1 upon a33 b3 minus a31 x1 nth iteration minus a32, right? These are constant, therefore raised to nth iteration is not written. X1, x2, x3, they are only unknown, therefore for them only raised to n is written, and that is nth iteration. It is not power. X2 raised to n, nth iteration, right? These are the formulas. That's it, right? Now we have to use these formulas and we have to find the successive approximations. Okay. Right now, note. Now question may be when, hope you remember the divergence and convergence of the series. So when these iterations will converge, what is condition for convergence of iteration process? Rather, the condition for convergence of iterations is mod of AII. You understand AII? This is diagonal element. Diagonal element of a particular row, ith row, is greater than summation of mod of Aij. Okay, J will vary. Just we don't have to consider diagonal element. काय झेपते कि नहीं, समझ में आ रहा है ये नहीं आ रहा है समझ में, समझते इसको? By an example we'll try to understand. Okay, this is the condition for iterations to be convergent. Okay, समझते, मतलब भी समझते हैं हम इसका. Okay, but let me start with one example. Okay, yes, start. Examples. Solve by Jacobi iteration method. Write the equations. 20x1 plus x2 minus 2x3 equal to 70. 3x1 plus 20x2 minus x3 equal to minus 18. Okay, 2x1 minus 3x2 plus 20x3 equal to 25. I am audible? Hope I am audible. मेरी आवाज आप तक पहुंच रही है ना? Right now?
Yes, sir.
Okay. Great. So okay. So is the system is diagonally dominant? यानी क्या करना है? You go through the equations. पहले x1 का coefficient देखो. Where it is largest, 20 is the, you have to consider numerical value. Minus sign छोड़ देना है. हाँ. So 20 is the largest number and that is the equation number 1. So this should be the equation number 1. No any change. Now see the remaining two equations. और उसमें you check the coefficient of x2. So it is 20x2 in second equation. That should be the equation number 2. Remaining will be the equation number 3. समझ में आ गया? Diagonally dominant है अभी. अब ये ऊपर का condition check करना है. हाँ. So say for I equal to 1, mod of I equal to 1 na, A11 should be greater than A12 plus A23. उनका भी mod लेना है. समझ में आ रहा है या नहीं? See the coefficient of पहला जो रो आएगा ना, if I write the matrix form तो ये ऐसे आएगा matrix form 21 minus 2, okay, 3, 20, minus 1, 2, minus 3, 20, okay, फिर x आएगा, फिर b आएगा, उनकी जरूरत नहीं है. So we are concentrating on the A matrix. So जो पहला element है, diagonal element है ना 20. So mod of 20 that is equal to 20. Is it greater than mod of 1 plus mod of minus 2? Check करो ये 20 है. Mod of minus 2 is 2. Yes, it is true for the first row. Second row में देखो क्या हो रहा है. 20 is it greater than sum of remaining two elements 3? Mod of minus 1 is 1 है ना. So 20 greater than 4. Yes, right. Second row में. Third row में जाओ अभी. Mod of 20 is it greater than mod of 2 plus mod of minus 3? Yes, 20 is greater than 5. So this condition is satisfied for the given system. ये इतना समझ में आ रहा है या नहीं आपको? Therefore, by Jacobi iteration method, the iterations will converge. Now question remains, after how many iterations will get a convergent answer? हाँ, इसको हमें देखना है, वो तो एग्जाम्पल से पता चले. ठीक है, करते हैं सॉल्व इसको. ओके, सो ऑन द नेक्स्ट पेज I'll write x1 from first equation, x2 from second equation, x3 from third equation. ठीक है, मुझे लिखने दीजिए, पहले मुझे लिखने दीजिए, बाद में आप लिखिए. ठीक है, so let me change the page. I'll write like this. First understand 34 by Jacobi iteration method. समझना है. I'm writing x1 from the first equation. So that is 17 minus x2 order में लिखना है plus 2x3. Okay, and then 1 upon 20. एक मिनट दीजिए मुझे. Okay, next I'll write x2 from the second equation. So already minus 18 is there. Minus 18, right? Then minus 3x1, x1 लिखना है पहले, plus x3, isn't it? Now let me use the, अच्छा ये 1 upon 20 बाकी है. Now x3 from the last equation. So 25, isn't it? Minus 2x1, isn't it? Plus 3x2, right? And then 1 upon 20. What our aim is to find n plus 1th iteration, so raised to n. So यहाँ पे n आएगा. Here we have n. Here we have n plus 1. Here we have n. Here we have n. Here we have n plus 1. n here. n. आ रहा है सबको समझ में? Getting? Are you able to understand these formulas? So now we have to start with the first iteration, right? 0th iteration. Okay, so we'll start with all of them equal to 0. So 0th iteration, that will be not given in example. You have to consider it. Now someone may say that what if I start with x1 equal to 1, x2 equal to 1, x3 equal to 1. Okay, you check that what happens. Okay, that is your choice, but usually for our examples we usually used to consider it as a 0. x1 raised to 0, x2 raised to 0, x3 raised to 0 equal to 0. 0th iteration is 0. So from above formulas, I'll say this as 4. So first iteration. Now we'll find first iteration. Understand how I am finding first iteration? Substitute n equal to 0 in equation number 4. Therefore, x1 raised to n equal to 0. 0 plus 1, 1. 1 upon 20. 17 minus x2 raised to 0 plus 2 x3 raised to 0. पता है ना हमें ये? So 1 upon 20, 17 minus 0 plus 0. So 17 divided by 20. कैलसी यूज करना है और कैलसी में आप फिक्स कीजिए up to 4 decimal places. 4 decimal places आपको आता है ना फिक्स करना? Please fix it. नहीं आता है तो नेट पे सर्च करना है. From here it is very difficult for me to tell all those things. Okay? So ये you have to understand it on your own. यानी 0.0000 इतना ही आना चाहिए. We should not get the 5th decimal places, 7th decimal places. That we don't want. Now you don't do in this way. You are getting answer up to 7 decimal places and you are writing first 4 decimal places. In that way, after some time, the answer will vary with your friends. So better to fix up to 4 decimal places and write the answer. Please do that. ठीक है? तो ये कितना आ रहा है मुझे बता सकता है कोई? Is it 0.85? And if few next numbers are there, they are 0, 0. Okay. x2 raised to 1. So 1 upon 20. Minus 18. Minus 3 x1 raised to 0. Plus x3 raised to 0. So 1 upon 20. Minus 18 minus 0 plus 0. So minus 0.90. एक बार चेक कर देना. ठीक है? Then x3 raised to 1. So 1 upon 20. Right? 25 minus 2 x1 raised to, I'm substituting n equal to 0. Then 3 x2 raised to 0. So 1/20, 25 minus 0 plus 0. Getting the 1.25. This is first iteration. Getting everyone? Write it and try to find the second iteration. Chalo. Any doubt? Ask me. If you have any doubt, let me know. कुछ डाउट है? अरे कुछ डाउट है क्या? चलो सॉल्व करो. हाँ चलो इसको सॉल्व करो. And those who understood, they can go through the second iteration, third iteration. Our aim is to find at least 4 to 5 or if possible 6 iterations. 6 इटरेशन फाइंड करते हैं. चलो देखते हैं क्या होता है. चलो सेकेंड इटरेशन फाइंड करो आप. यूज कैलसी. फिक्स इट अप टू 4 डेसिमल प्लेसेस. गो अहेड. Have you obtained second iteration? चलो second iteration. So x2 sorry x1 okay. x1 raised to 2. 1/20. 17 minus x2 raised to 1 आएगा है ना. 2x3 raised to 1. So 1/20. 17 minus x2, already minus is there, minus minus plus 0.90 plus 2 into 1.25. कैलसी यूज करो और देखो क्या आ रहा. Then x2 second iteration 1/20 minus 18 minus 3 x1 raised to 1 x3 raised to 1. So 1/20 minus 18 minus 3 into x1 0.85 plus x3 1.25. Okay, and then last value x2 x3 1/20 25 minus 2 x1 raised to 1 plus 3 x2 raised to 1. 1/20 25 minus 2.85. Okay, plus 3 minus 0.9. हाँ, who got these answers? किसको मिले ये आंसर मुझे बताओ क्या आ रहा है. What is x1 raised to 2? What is the second iteration of x1? Anyone?
4.25.
Correct? Yes, correct. It was correct value.
4.25.
4 kas kai?
1.02.
1.02. Correct. Next. X2 raised to 2.
minus 0.965.
Absolutely. Minus 0.965. Last value. X3. Yes, X3. अरे बताओ
1.03.
नहीं 1.03 नहीं 1.1515 check it 1.1515 okay calci थोड़ा सा whenever required ना use the brackets while using the calci so that you will get correct answer everyone is getting 1.1515 थोड़ा check करना है आपको बी केयरफुल अबाउट द साइंस साइन जो भी है वो ठीक से आप ले लीजिए ओके ग्रेट गो टू द नेक्स्ट पेज फाइंड थर्ड इटरेशन एनी डाउट चलो थर्ड इटरेशन फाइंड करते हैं लेट मी चेंज द पेज these values are known to us from the previous part second iterations what they are 1.02 है ना ये पता है हमें so x1 third iteration 1/20 किधर गया 1/20 17 minus x2 raised to 2 है ना plus 2 x3 raised to 2 okay then x2 raised to 3 third iteration 1/20 minus 18 minus 3x1 raised to 2 plus x3 raised to 2 x3 second iteration 1/20 25 minus 2x1 raised to 2 plus 3x2 raised to 2 है ना सब वैल्यू पता है हमें yes substitute them I'll substitute them in this case in next case I'll write the answer directly 17 minus x2 I can write plus minus minus plus 0.965 minus minus plus is written 2x3 1.1515 okay and answer will write here 1/20 minus 18 minus 3x1 plus x3 in this case also we have to write answer in this way okay and then last 1/20 2x1 use calci carefully and find these three values yes who got the answer up to 4 decimal places. Who got the answer? किसके आंसर्स आ रही है बताओ मुझे थोड़ा सा. Yes.
1.0134.
Absolutely. 1.0134. Good. Next.
Minus 0.9954.
9954, right?
Yes, sir.
Very good. Last. Check the last one. 1 point something.
— 1.0032.
Absolutely, absolutely. So now you might have observed that x1, x2, x3, they are converging to a specific value that we can predict at this moment. x1 is converging to 1, x2 is converging to -1, x3 is converging to +1. 1 minus 1, 1. Okay, they are converging to these values. They are little bit away from these values. Okay, and maybe next iteration will get nearer values. We'll check that, right? Till if you have any doubt, ask me. Fourth iteration. So third iteration is known to us. Use these three values. Now I think you might have understood what the procedure is. Simultaneously, can anyone tell me how we can modify this procedure? Or in other words, I want to ask how the speed of convergence can be increased. How we can increase the speed of convergence? This is the question. Yes. Who got the next solution? Four it should be. अरे बताओ क्या आ गया ये? ओम दानम बताओ क्या आ गया? What the answers are?
1.011.
1.00.
1.0110.
No. Whatever answer I have is little bit change is there. हाँ बोला? बोला? नाही ते ॲक्युरेट आन्सर यायला पाहिजे ना. 1च्या आसपास आन्सर आहे आणि आपल्याला लिटरेशन 4-5 काढायचे. फक्त 1 पॉइंट समजा 13 घेतलं तर त्यातून काही कळत नाही ना. त्यामुळे नाही अरे हे आन्सर आहे ना, तुला ते इटरेटिव्ह मेथड्स आहेत ना, डायरेक्ट तुला कसं बनवता येईल? आता समज तुला रॉकेट लॉन्च करायचं आहे आणि तुझा आन्सर आहे 1.0000056 कशाचे कुठल्या एखाद्या प्रोसेसचं, तर ते 1 घेऊन चालेल का ते पूर्ण घ्यावं लागेल? हा त्यासाठी ठीक आहे. मग ते एरर जास्त होईल ना, एरर वाढत जाईल देअरफॉर. ठीक आहे. Okay, so check whether your answers are like this. 1.0134 minus 0.9954. Okay, 1.0034. Please check your answers. Find next iteration. Find 6 iterations. Go ahead and find the 6 iterations. Fifth iteration. So x1 raised to 5. Please write the formula. x2 raised to 5. x3 raised to 5. Find up to 6 iterations. 5 iterations are sufficient, but for this example, we will find 6 iterations. Why we'll understand. Why we are finding 6 iterations, that also we'll understand at the end. Find 5th iteration first. So it is like this. Check your answer. So now see, it converges to 1. Minus 1.002. 0.9996. Okay, now we have to find the next iteration, 6th iteration. Okay, can I change the page? Kardu page change.
Sir, 1 minute.
Okay, go ahead. So you should have scientific calci and you should have good knowledge of the calci. Okay, go through the YouTube. There may be 1 or 2 hours session may be there on how to use the calci. Okay, or if any one of you is interested in taking a session on how to use the calci, please we'll find some time and we'll have a session on that.
Hello.
Yes. बोला.
सर आवाज चेक करत होतो येतोय की नाही.
हा येते. अरे तुझा आवाज छान आहे, काय प्रॉब्लेम नाही.
सर आधी येत नव्हतं.
Okay, no problem. चल, I'll change the page. 35, 36 now. At 6th iteration. Hope there is no any confusion. Substitute n equal to 5 in 4. So x1 raised to 6, x2 raised to 6, x3 raised to 6. Please tell me what the iterations are. So sixth iteration is like this. Check your answer. And now if you find next iteration, you will get same value again and again. You can cross check it. Tabulate all the values. First, started with 0, 0, 0. And this was the first iteration. What was the second iteration? Third iteration. Fourth iteration. Understand how the answer is converging. This is the answer. Right? So you might have understood at every step we are getting one answer. Not the accurate answer, but we are getting answer of x1, x2, x3, and therefore they are not known as direct method, they are known as iterative methods. Okay, so here we'll stop. We'll have lecture on Monday. We'll go through one more example of this type, or I think not so much important. We'll go through the next method. If you want, we'll have one more example of this method, and then a question is at this moment. Question is how we can modify this method so that the convergence will be fast. इसको आपको थोड़ा सा सोच के रखना है. ठीक है? चलो मिलते हैं. Let me take the attendance. Just 1 minute only. I'll download the attendance. Yes, I have downloaded it. You can leave now. Thank you. Bye bye. Any doubt at this moment?
No, sir. Thank you, sir.
Oh.
Thank you, sir.
Thank you, sir.
Bye bye. Bye bye. Good day.
Thank you, sir.
Okay.
सर परत लेक्चर होणार
नाही आज नाही आता मंडेला.